Welcome to this explainer. We're diving straight into what I consider to be the ultimate 2,000-year-old architectural mystery: why ancient Roman structures completely outlive our modern engineering marvels. I mean, think about the paradox here. We've got supercomputers, incredibly advanced chemistry, and laser-guided construction equipment, right? Yet, the modern highway you probably drive to work on is already full of potholes. Meanwhile, there are ancient Roman monuments standing outside right now that haven't been repaired in 2 millennia. How is that even possible? Well, today we are going to unpack the chemistry, the engineering, and really the philosophy behind a material that literally changed the course of human history.
It's a pretty wild contrast when you put them side by side. Our modern concrete is designed to reach its maximum strength super fast, but the trade-off is that it slowly degrades over just a few decades. Moisture seeps into these tiny microcracks, the steel reinforcement rusts, it expands, and the concrete essentially just fails from the inside out. But on the flip side, ancient Roman concrete lasts for millennia. It actually heals its own cracks, and incredibly, it gets stronger when exposed to seawater. It's honestly almost like the material is a lot.
So why did they even invent this stuff in the first place? Well, picture ancient Rome at its absolute peak. This was a booming metropolis of over 1 million people. It was the largest city the world had ever seen, and it was just constantly growing. They needed massive temples, theaters, and apartment blocks rising up 5 stories high. The problem was, traditional building methods had some really severe limits. Stone was incredibly heavy, super expensive, and painstakingly slow to work with. Plus, stone couldn't span the vast interior spaces they needed without using a whole forest of supporting columns. Rome wanted to build the impossible, and to pull that off, they needed a material that simply didn't exist yet. So, they invented it. Okay, let's break down this recipe, which honestly seems deceptively simple. The Romans discovered this peculiar volcanic ash near Mount Vesuvius, and it completely changed the game for engineering. They mixed 1 part lime, which they got by burning limestone, with 2 parts of this volcanic ash. They called it pulvas puchuanus, but today we just call it pozzolana. Then they added water and mixed in chunks of rock, broken brick, or rubble just to give it some bulk. Mix all that together and you get this thick paste that could be poured into molds, hardened like stone in a matter of days, and actually became stronger than stone within months. Now here's where it gets really cool. What the Romans couldn't actually see and what scientists literally just figured out is the microscopic magic happening inside that paste. It's called the pozzolanic reaction. When that specific volcanic ash meets the lime and water, it triggers a totally unique chemical reaction. The silica and alumina bond with calcium to form these intricate interlocking crystals. And these crystals grow directly into each other, binding all the sand, rubble, and ash together into this ridiculously dense, unified mass. And those interlocking crystals? That is exactly why this material seems practically immortal. Instead of hitting its peak strength and then rotting from the inside out, like modern Portland cement does, the Roman chemistry never actually stops. When microcracks inevitably form in the structure, because, things shift over 2,000 years, water seeps in. But instead of rusting internal steel, that moisture just reactivates the dormant lime and volcanic ash. The chemistry kicks right back in, actively filling in its own cracks and growing stronger as it ages. It doesn't just sit there resisting damage, it actively self-heals. But wait, this self-healing property gets even crazier when you throw oceans into the mix. The Romans built these massive artificial breakwaters at places like Caesarea Maritima. They literally sank wooden forms directly into the Mediterranean Sea and poured concrete right into them to create these sheltered ports, which naturally prompted modern scientists to ask, how on earth was this stuff setting and surviving, completely underwater, getting absolutely hammered by relentless ocean waves and saltwater storms for 2 millennia? Well, here's the brilliant catch. They actually deliberately mixed their marine concrete with seawater. For centuries, modern engineers assumed this had to be a mistake, right? Because seawater absolutely eats our modern concrete alive. But for the Romans, this was a brilliant, highly observant engineering choice. The salt water actually triggered rare mineral formations within their specific pozzolanic mix, causing the concrete to literally thrive and become stronger when submerged. They perfected these recipes over generations of patient observation, figuring out exactly what worked in very specific environments. If you want the ultimate proof of just how incredibly powerful this material is, look no further than the Pantheon in Rome. Built around 126 AD, it features this massive 143-foot dome, and sitting right above the heads of everyone standing inside is over 4,000 tons of solid, unreinforced concrete. No steel rebar, no internal metal framework, just 4,000 tons of rock and ash hanging directly above your head. Modern engineers have literally called this structure an impossibility, yet it's still standing there today, perfectly intact.
So how does it survive? It all relies on this genius concept, graduated density. The Romans knew the base of the dome had to bear an enormous amount of compression, so they mixed the concrete down there with really heavy basalt and travertine aggregate. But as the dome rises and curves inward, they changed up the mix. They use lighter brick in the middle section, and at the very top they use volcanic pumice. Pumice is a rock so incredibly light that it literally floats on water. So the dome gets progressively lighter as it goes up, which significantly reduces the load on the walls below. They also pulled off a structural masterstroke by basically just removing the most stressed part of the entire dome, the very top, the crown. They left a perfect circular opening up there called the oculus. This wasn't a weakness, it was a brilliant way to turn an engineering headache into this stunning light source. And sure, because it's completely open to the sky, rain definitely comes in. But they thought of that too. The floor below has this very subtle convex curve that catches the rainwater and channels it directly into drainage holes around the perimeter. 2,000 years of storms and the dome has never leaked and the floor has never flooded. Beyond just sheer strength, concrete completely liberated Roman architecture from the strict limits of carved stone. Think about it. A marble column required a master stonemason and months of tedious, precise carving. But concrete? You could have unskilled laborers poured into a mold in mere days. It unlocked entirely new shapes, like these massive sweeping arches and huge vaults, essentially democratizing the whole building process. And crucially, it was highly fire-resistant. When the Great Fire of Rome devastated the city in 64 AD, burning the wooden buildings and cracking the stone, the concrete survived. After that, Emperor Nero actually made concrete construction mandatory for rebuilding the city.
And you know, this material wasn't just reserved for beautiful, grand monuments, it was the everyday, essential backbone of civilization itself. For entertainment, you had concrete vaults handling the stampede of 50,000 rowdy spectators moving in and out of the Colosseum. For housing, it allowed for the creation of insulae, these apartment buildings rising 5 to 7 stories high, giving the urban masses secure, fire-resistant vertical housing. And for infrastructure, it built the aqueducts and the harbors that quite literally kept the empire alive. It's what allowed 1 million people to live safely in a sprawling, highly advanced urban jungle.
But tragically, history took a pretty dark turn. Around 30 BC, the famous architect Vitruvius meticulously recorded these brilliant concrete recipes, but when the Roman Empire fell, the knowledge was completely lost. It wasn't burned in some dramatic fire, it was just slowly, quietly forgotten. For over 1,000 years, medieval builders just stood in awe of these Roman ruins, completely unable to replicate them. It wasn't until 1824 that we invented modern Portland cement, which, again, is faster and cheaper, but ultimately weaker. And get this, it actually took until around 2017 for scientists from MIT and Berkeley to finally crack the code and discover the seawater and self-healing secrets of that ancient Roman mix.
Ultimately, though, this whole mystery of Roman concrete isn't just a story about cool chemistry. It's profoundly about philosophy. Today, our whole system optimizes for maximum speed and the cheapest possible cost. We accept massive carbon footprints to build structures that we fully know will crumble in our own lifetimes. But the Romans? They relied on patient observation. They engineered through hard-won experience over centuries, and they had the audacity to invest the time and effort into creating something that would outlast them by 100 generations. They chose to build for eternity. Today, as scientists are actively working to recreate the self-healing, low-carbon material for us to use in the modern world, it leaves us with a pretty profound realization. We finally have the technology. We finally understand the chemistry. So as we look ahead to planning the cities of tomorrow, we have to ask ourselves, will we finally abandon this age of disposable construction and choose once again to build for eternity?